Without using table, find the value of sine 15. Now, the problem is just sine 15. Now, sine 15, now we'll look at what are the values of these special angles that when you subtract or add, you will get sine 15. Now, if you look at 60 and 45, so if you subtract this, you have 15. So that means we can now use, we can say sine 60 minus 45. Now, according to a trig rule, you have sine A minus B is equal to sine A cos B minus cos A sine B. So applying this rule, we can now say sine 60 minus 45 is equal to sine 60 cos 45 minus sine 45 cos 60. So then now that means now let's look for the values of sine 60 and the values of cos 45. Now from the diagram, a equilateral triangle where all the sides are equal, the angles are all equal. Now if the angles are all equal and the sum of angles in a triangle is 180, that means for all the triangles to be equal, that means it should be each of the angles should be 180 divided by 3, which is 60 for each of them. Now if you bisect the triangle, you have, now let's assume the length of the triangle is 2, let's say 2 units. Now if you bisect this triangle, here will be 1, here will be 1. So when you add these two is 2. So now the length of this place, this side, you cannot get it using the Pythagoras theory. Now let's say here is C, here is A, here is B. Now using Pythagoras theory, C square is equal to A square plus B square. Now we're looking for B. B square is equal to C square minus A square. So if you move this to the side, it becomes minus. Now C is 2. C is 2. So 2 square minus A, which is 1 square. You have 4 minus 1, which is 3. So B will now be, taking the square root of both sides, this will now be B equal to what? Square root of 3. So here is square root of 3. Now, sine 60. Sine, let's remember what we call this SOHCAHTOA. Now, SOHCAHTOA, you have sine, which is opposite all over hypothesis. Now, the opposite of this angle is this, which is square root of 3 divided by the hypothesis, which is 2. Then now, cos 60 is equal to the adjacent, which is this. The adjacent to this one is this. So 1 all over 2. So that is it. So now, So then now let's also now look for 45 cos 45 and sin 45. Now for you to now here is 90. For you to make here 45 and here 45, so this side is supposed to be equal to this side, which is, we assume, is 1. Here is 1, because if here is 1, here is 1, then this angle should be equal. So for this angle to be equal, we have here 1, here 1, here should be square root of 2. So that means sine 45 is equal to what? So the opposite of this 45 is 1. Now, which is 1, which is 1 all over what? The hypothesis, which is root 2. Now, and you know that sine, sine theta is equal to what? Cos 90 minus theta, which means that sine 45 is equal to cos 45. Because if you put 45 here, if you put 45 here, you have 45 too. So that means this is equal to what? Cos 45. So we are going to now make use of that. So now we have sine 60 minus 45, which is equal to sine 15. This is equal to sine 60 cos 45 minus cos 60 sine 45. So sine 45 is so sine 60 is square root of 3 all over 2 times cos 45 is 1 all over square root of 2 minus cos 60 is half times 1 all over square root of 2, which is sine 45. Sine 45 is the same thing as cos 45. So we now have this root 3 times 1, you have root 3, 2 times root 2, you have 2 root 2 minus 1 times 1, you have 1, 2 times root 2, you have 2 root 2. So since the denominators are the same, we'll add the numerators. So root 3 minus 1 divided by 2 root 2. So but I needed to simplify this further. I will say root 3 minus 1 divided by 2 root 3 root 2. Now what we do, we multiply the numerator and the denominator by the conjugate of this. I will just, instead of multiplying them with the whole of this, I will multiply with only root 2. So I will just multiply the numerator with root 2 and the denominator with root 2. So root 2 times root 3 will give you square root of 6 minus the square root of 2 divided by this times this will give you what? 4. So this is the final answer.